Hello everyone, I am Sixiang, a 6-year PhD student from the Ohio State University. In this talk, I will present our work that tries to find the heterogeneous unsafe configuration parameters in cloud systems. This is joint work with Fang, Mike, and Yang, also from the Ohio State University. While many distributed systems are still using homogeneous configuration for the whole cluster, heterogeneous configurations are becoming more and more popular for several reasons. First, heterogeneous hardware naturally calls for heterogeneous configurations to achieve better performance. For example, many systems allow admins to set different thread numbers, memory sizes, bandwidth limitations for different nodes with different hardware. Secondly, heterogeneous configuration can also occur during online reconfiguration. Online reconfiguration is a nice feature which allows admin to reconfigure the system at runtime without hurting system availability. To achieve this feature, some systems like HDFS will provide a reconfigure command to allow admins to update the configuration of a node without rebooting it. And the rolling restart is another solution to achieve this feature, which works by incrementally rebooting some nodes for reconfiguration while keeping the whole system online. While online reconfiguration is beneficial, it creates a short window of heterogeneous configuration. Unfortunately, the existence of heterogeneous configuration in distributed systems may cause problems, even if each individual node is configured correctly. For example, suppose we have a parameter called encrypt, which determines whether messages between nodes should be encrypted or not. Let's say we have a configuration file f1, which sets this value to be true, and f2 that sets this value to be false. When we assign the same configuration file to all the nodes in the system should work correctly. However, as shown in the third figure, when we configure some nodes with f1 and some with f2, errors can happen in the system because the communication between some nodes may fail. In this work, we call this type of configuration as invalid heterogeneous configuration. And we call the corresponding parameter as heterogeneous-unsafe configuration parameter. Please refer to our paper for the formal definitions. Well, it might be obvious to some people why the encryption parameter is heterogeneous unsafe. Some other problems that heterogeneous configuration can cause might not be that obvious. For example, there is a parameter in HDFS called bandwidth per second, which is used to specify the maximum bandwidth that a data node can use for balancing purpose. Surprisingly, we found that this parameter is also heterogeneous unsafe. Let me show you with one example. Here, a system admin is trying to use the balancer tool provided by HDFS to rebalance the system by moving some data from data node 1 to data node 2. During this task, data node 2 is responsible for sending task progress message back to the balancer periodically. When both the data nodes are configured with the same value, for example, 100, the task can finish successfully. This is also true when we configure all data nodes with a value of 10. However, when we set 100 on data node 1 but 10 on data node 2, errors can happen because the progress reporting message will be throttled to be sent out from data node 2, as it may use up its bandwidth quota when receiving data from data node 1, which has a higher bandwidth limitation. As a result, the balancer will finally time out and report this task as failed. As one can see, this type of configuration errors is different from the problem of erroneous configuration values, which has been extensively studied before. In our case, all the parameter values are valid, and the error happens when nodes with different configurations communicate with each other. So in this work, our goal is to find what parameters are unsafe for heterogeneous configuration in cloud systems. For this purpose, we design and build a testing framework called ZebraConf, which uses existing unit tests to test the heterogeneous configurations. ZebraConf detects 41 heterogeneous unsafe parameters after we applied to 5 popular cloud systems. ZebraConf uses a classic software testing approach. It will test the target application with different heterogeneous configurations to see whether they cause errors or not. When we started to implement this idea, we met the general software testing challenge that we find many configuration parameters are not used under simple workloads because the pieces of the code that use these parameters are not triggered. Fortunately, we also observed that many mature cloud systems have rich unit test suites, which are supposed to cover testing of most system functionalities. Our further analysis shows that among those unit tests, many of them are using configuration parameters when testing. This observation motivates us to design a testing framework that can reuse existing unit tests to test the heterogeneous configurations. However, implementing this idea is not easy. There are 2 major challenges we met. First, we need to reduce the testing time. In our study, we found it is common for a cloud system to have thousands of unit tests and hundreds to thousands of parameters, and a unit test will usually run for several seconds to several minutes. If we simply test all the combinations, the testing time would be completely impractical. Second, the task of assigning different configurations to different nodes is challenging in unit tests. This task is easy in a distributed setting where nodes are created as processes, because we can directly specify the configuration file when launching a node. However, this approach doesn't work in unit tests. To solve these challenges, we design and implement ZebraConf, which consists of 3 key components. At the top layer, TestGen is responsible for generating test instances by giving parameters as input. A test instance is a tuple of a unit test and a heterogeneous configuration. After tests are generated, test runner will execute each test and ask a conf agent to assign the required configurations to nodes when running a unit test. We rely on TestGen and TestRunner to address the first challenge, and rely on conf agent to solve the second challenge. We have proposed several techniques for each component, and due to time limitation, I will only discuss the pre-run profiling and the design of conf agent in this talk. Let's first look at the pre-run profiling. Before I talk about the technique, let me first show you what a test instance is. In ZebraConf, a test instance is a tuple of a unit test and a heterogeneous configuration of F1 and F2, which is actually the assignment of F1 and F2 to nodes. From this formula, we can see that the test number can be very large because of the massive number of possible configurations and assignments. To reduce the test number, ZebraConf chooses to test each individual parameter instead of their combinations. To further reduce, we propose a technique called a representative assignment, which is used to reduce the number of assignments by only testing selective value to node assignments for each type of nodes. Please refer to our paper for the detail of this technique. By doing these 2 reductions, we can reduce the test number to U multiplied 2P multiplied 3T, where U is the number of unit tests, P is the number of parameters, and T is the number of node types. However, the test number is still too large. For example, in HDFS, 387 millions of test instances will be generated. Fortunately, we observe that not all the combinations of unit test, parameter, and node type are effective when testing. This observation creates opportunity to further reduce the test number by filtering ineffective tests. To perform this idea, ZebraConf will run each unit test once to collect the meta information about the unit tests. Particularly, ZebraConf will record for each test which parameters are read by which nodes with what values. After this stage, TestGen will leverage this information to filter ineffective combinations. For example, when TestGen is trying to generate tests for parameter encrypt, it will skip the test instance of test1 encrypt node B, because it knows that in test1, encrypt is not used by node B. Our result shows that pre-run profiling is very helpful. Now let's talk about the design of conf agent, which is responsible for assigning different configurations to different nodes. This task is trivial in distributed setting because we can directly assign different configuration files to different nodes when launching them, so that nodes can read the different parameter values automatically. Unfortunately, this approach doesn't work in unit tests, where nodes are often created as threads within a single process. After some failed attempts or some other directions, we decide to implement our solutions with the following key idea. We will try to attribute every configuration object to a node and hack the return value based on the attribution. However, there are two major challenges we have to solve with this idea. First, one node can have multiple configuration objects, which can be created either during node initialization or dynamically. For example, a node receives certain requests. Second, configuration objects can be shared among nodes, which means that when we update a configuration object, its value can be seen by multiple nodes. If these two problems are not properly handled, a node may read inconsistent values, which will cause false positive. Now let's move on to conf agent's solution. First, to stop sharing, conf agent will clone the configuration objects that can be shared among nodes, so that each node can only read from their own configuration objects. Second, conf agent will track the configuration creation flow at runtime and try to attribute the configuration objects to nodes by using some heuristic rules. For example, if we know configuration object B is cloned from configuration object A, and A belongs to node 1, then we can induce that B also belongs to node 1. Please refer to our paper for the other rules. In the meanwhile, conf agent will keep track of those configuration parameters that cannot be certainly attributed and avoid testing parameters that are read from these uncertain configuration objects. Finally, to mimic different nodes are using different configurations, conf agent will manipulate the return value for every configuration read operation based on which node the configuration object belongs to. Now let me show you some evaluation results about ZebraConf. We run all the experiments on Cloud Lab, and we have applied ZebraConf to 5 popular cloud applications, namely Hadoop HDFS, Yarn, MapReduce, as well as HBase and Flink. We found that the modification overhead is generally small, as only 18 to 38 lines of code needs to be modified. The total running time is about 4,600 machine hours by using up to 100 physical machines, each running 20 Docker containers. In the experiment, ZeroConf totally reports 57 heterogeneous-unsafe parameters, and after our manual analysis, we found 41 of them are true problems. Among these unsafe parameters, many of them are related to, for example, specified data transfer formats, timeout values, maximum limits, or task numbers. It is not difficult to imagine that the system will run into issues when people configure these parameters differently. However, besides these parameters, ZeroConf also detects some unexpected heterogeneous unsafe parameters. For example, there is one parameter called max concurrent moves in HDFS, which limits the max numbers of threads that a data node can use for balancing. Notice that this parameter will be used by both data nodes and the balancer. When we set the parameters to 50 or to 1 on all the nodes, the balancing task can finish in 14 and 16 seconds respectively. However, when we set the balancer with 50 and the data nodes with 1, the task finishing time will be 10 times longer than the case when using a single thread. After some investigation, we found that this problem is caused by that balancer is unaware of the one thread capacity setting on data nodes, and it sends too many concurrent move requests to data nodes. As a result, most of the requests will be declined by data nodes, and the congestion control mechanism will be triggered. We found a similar problem has been discussed in HDFS community. HDFS users have reported that the current balancer mechanism doesn't work correctly when data nodes are configured differently. For example, when users are running different nodes on different storage tiers. A workable solution that the user proposed is to let the balancer fetch the thread number from each data node. Now let me show you some results about the testing filtering. These results try to answer two questions. First, how many ineffective tests are filtered by using pre-run profiling? Second, how many tests will be filtered because of uncertainty? The first row in the table shows the number of tests without using pre-run profiling. We can see the test numbers are very large. By filtering ineffective tests with pre-run profiling, the numbers will drop significantly. The last row in the table shows the test number after removing uncertain cases. We can see that for 4 applications, less than 5% of tests will be filtered, and 10% of tests are filtered in MapReduce. These results show that conf agent solution is simple but efficient, as most configuration objects can be attributed in most cases. In conclusion, today I talk about our testing framework ZeroConf that can reuse existing unit tests to find heterogeneous unsafe parameters. It helped us to find 41 unsafe parameters in 5 popular cloud systems. Our experiments on debugging these parameters shows that systems may need to provide better support when using heterogeneous configurations. We have made ZeroConf available at GitHub. This is all of my presentation today. Thank you very much.